Hey guys, this is a video on graphing polynomials and dealing with multiplicity. Let's say we start with an equation like this. Y equals x minus 1, x minus 2, x minus 3. Now if we wanted to go and graph this equation, this is the x-axis, this is the y-axis. Then I can choose any x value I want, and if I plug it in and do the math, I'll get a y value that goes along with it. Now, it turns out there are some values that are really easy to graph. These are the values of x that make a 0. So here's a little table. And I'm going to choose a value of x and see what happens to it. Let's choose a value of x is 1. If I get that 1 and I plug it into this equation, then this 1 is going to go right here and replace that x. So now my equation becomes, underneath here, 1 minus 1, 1 minus 2, 1 minus 3. 1 minus 1 is 0, and 0 times anything is going to be 0. So my x value is 1, my y value is 0. Okay, let me clean that up a little bit. And now let's talk about the other values of x that are going to make a 0. So when x is 2, I also get a 0. Because when I plug the 2 in here, 2 minus 2 is 0. The whole thing turns to 0. So 2 is 0, 3 is 0, and what if I had x plus 1? Well, if it's x plus 1, the negative 1, it makes a 0, because if negative 1 gets plugged in there, I get a 0. So the way we graph this is we plot these points. So 1 goes to 0, 2 goes to 0, 3 goes to 0, and negative 1 goes to 0. Now, overall, this graph is a 4th degree quadratic. 4th degree because I have 1, 2, 3, 4 x's. So overall, because it's a 4th degree, it's going to make some kind of a smiley face. Might have some wiggles in between, but overall, it's a smiley face. So that means when I graph it, I'm going to come and approach this one, this value right here. I'm going to approach this from above. And this one right here, I approach from above too. And now I just have to go up and down and weave through these zeros right there. Okay, let's do another one. So let's say I have something like this. X minus 2, x plus 3, x minus 1. I'm going to pause the video for a second and think about where it goes through the x-axis. Okay, so this one right here, that's going to go through at 2. This one right here is going to go through at negative 3. And this one right here means I flip the sign and I go through at positive 1. Okay, so now this is a first, second, third degree polynomial. Third degree polynomials behave like this. So I approach this one from below, and then like this, and that is my polynomial graphed. Okay, now what happens if you have a double root? So if you have a double root like this, x plus 1, x minus 2 to the second power, x plus 3. So first of all, we draw our roots. This first one gives us a negative 1. Remember, we're flipping these signs. This gives us a positive 2, and this one gives us a negative 3. Now, this one is special because it's a double root. So we are going to put an extra little circle around that point to remind ourselves that something interesting happens there. Now, this is a what degree polynomial? This is 1, 2, 3, 4. There are 4 x's. If I multiply this out, it would be x to the 4th, something, something, something. So because it's a 4th degree polynomial, it has to behave something like this. So it's approaching this first point right here from above. It's approaching this point from above. It also has to go through this point. So let's just see if we can connect the dots. It goes through here, it has to go up through there. Now it can't cross the x-axis again, because if it did, it would create a whole other x-intercept, which we can't have. So it comes here and it touches, and it goes back up again. All right, let's do something similar, except now instead of making this a 2nd degree polynomial, let's make this guy a a triple root at that point. So it still is going to go through -1. It's still going to go through +2. It's still going to go through -3. But now it's going to go through them differently. Overall, now we have a 1, 2, 3, 4, 5, a fifth degree polynomial. Fifth degree polynomials behave like this. You might have a couple wiggles and then back up again. So I approach this first point from beneath. I approach this point. Now it seems as though I can just go on and graph it like this, and I satisfy the end behavior. I go through all the roots, it seems fine, but I haven't addressed the fact that this behaves a bit differently than the other roots. And this is how triple roots behave differently. It does go through this one, it does go through this one, but it approaches this one kind of shy. It doesn't want to go straight through, it kind of flattens out, and it goes up again. Let me see if I can draw that more smoothly. Up, down, kind of flattens, and then kind of up. So it's kind of subtle, but you can see the sort of flattened area right there. So the overall summary is this, for multiplicity and for graphing. If somewhere in your equation you have x minus 2x, hang on. So you could have a whole bunch of these things. If you have this as a single root, so no number there, but a single root, then it's going to approach the number 2 like this. It's going to go straight through, or it might approach 2 like this. But it'll have one of those possibilities. It's going to go straight through 2. It's going to behave around 2 like a line. Now here we've got something. We've got x minus 2 to the second, something, maybe something else. In this example, because this is squared, it's going to behave around the number 2 like a quadratic. And finally, if you have something like this, some kind of factor, and you have x minus 2 to the cubed, then it's going to behave around 2 like a third degree polynomial. So it's going to behave like that, or maybe it behaves like this. You'd have to check overall the end behavior to figure out which way you're going through it, but it approaches it like a cubic. Now you can end the video here, but if you want to understand why, then watch for another minute. I'll explain the reason why it behaves that way. If you have something, x minus 2 squared, something, then let's see what happens as you approach the number 2 from either side. If I pick a point right here, 2.01, and I plug this number into this equation, that's going to give me 2.01 minus 2 squared. And I have some other numbers here. These other numbers are probably normal numbers, like 5-ish at this point. They're like 6-ish or negative 10-ish. They're just kind of normal numbers. The one that's really interesting, though, is this one in the middle, because 2.01 minus 2, that's the same thing as 0.01. Now, when we square it, that's going to end up being 0.0001. Now, again, this number here is something tame, like 5-ish, and this one is 6-ish. So compared to those other numbers, the one that really matters is this one. The fact that when you get really close to 2 on the right-hand side, that almost 0 number multiplies by these other normalish numbers to produce something that's really, really close to 0. So that means on the right-hand side of this thing, despite all the other factors, despite everything else that's going on, you have a point right here that's really close to 0. Now, if I move to the left and pick a number on the left-hand side, like 1.99, and I plug that number in, if I plug that number into the equation, then I do 1.99 minus 2, which is going to be negative 0.01. And when I square it, it's going to be 0.0001. Because a negative number, when you square it, is positive. Now, these other numbers on the left and the right, these are just normal numbers like 5-ish and 7-ish or whatever they are. But the one that really is doing all the work is this one right here, which is bringing that whole polynomial dangerously close to 0, but on the positive side, a positive, really, really small number. So when I graph it on the left-hand side, because that negative number gets squared, it's bringing it up right here. That's why it behaves like a quadratic at that point, even though you might have some other numbers doing some other things as you get further and further away from that. In the neighborhood of 2, it's this that matters, because these numbers close to 2 on the left and the right are pushing the whole thing really close to 0. Now the same thing happens with the third degree, so x minus 2 to the third power. I'm not going to write the other terms out, but if I had some number like, if x is on the graph, actually, this is 2. If x is 2.01, then I get 2.01 minus 2, which is going to be 0.01. And when I cube it, it's going to be 0.000001, which is a really, really, really small number, but it's positive, and so it's going to be some number right here. Okay, now what if I choose some number to the left of it? Like if I choose 1.99, 1.99 minus 2 is going to be negative 0.01 cubed. And when I cube a negative number, it's going to be negative 0.000001. So it's a negative, really, 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 really small number. And so when I graph it, that means on the right-hand side, it's a positive, really small number. On the left-hand side, it's a really small number. Now, once I get over to 3, once I get numbers bigger than, as long as this is more than 1, and as long as this is more than 1 on that side, then those numbers start to get big really fast. So after I get beyond this, it starts to go really steep. And once I go here, it gets really steep on that side. So that last bit of the video is kind of the why of works. But again, the key for getting these right is if it's x minus 3, then it's going to go through 3 like that. Or maybe it's going to go through 3 like this. If it's x minus 3 squared, then it's going to look like this at that neighborhood around 3, or it's going to look like this. And if it is x minus 3 cubed, then at the 3, it's going to behave like a third degree polynomial, either a positive one or a negative one, depending on your context.